Welcome back, everybody. We're diving into a paper today all about deep learning.
Oh, yeah.
Yeah, deep learning
hmm
and how to make it even better for cybersecurity,
Okay. Interesting.
specifically in the area of side channel attacks.
Side channel attacks.
You ever heard of those?
Oh, of course. Those are the ones where you kind of exploit information leakage from a system,
Right.
not directly going after the algorithm.
Yeah,
It's more like the physical implementation.
like trying to crack a safe, not by picking the lock,
Yeah,
but by listening really closely to the clicks of the tumblers.
exactly. That's a great way to put it.
So this paper, it's called Autoencoder-enabled Model Portability for Reducing Hyperparameter Tuning Efforts in Side Channel Analysis.
Wow, that's a mouthful.
Yeah, it is. But the key words here
Okay.
are autoencoders, portability, and hyperparameter tuning.
So making these models easier to use in different situations.
Exactly.
Less time-consuming to train.
That's the big question. Can we actually make these deep learning models more adaptable for new side channel attack scenarios?
Interesting. I mean, I know from experience how much time and effort goes into training these models.
Oh, tell me about it. It's
All
like
right.
every time you get a new data set, you have to start from scratch.
Yeah, it feels like it. You're constantly tweaking those hyperparameters, just trying to find the perfect recipe for that specific data set.
So much trial and error.
Ugh, it's
Yeah.
frustrating and it takes forever.
But these autoencoders, they're like the heroes in this story.
Oh, really?
Yeah, they take these big, complex data sets and they, like, I don't know, almost like compressing a file.
Oh, I see, like a ZIP file.
Yeah, you get a much smaller package, but you don't lose any of the important details.
So you're saying it learns a compact representation of the data.
That's it. And the cool part is, by simplifying the data this way, it actually becomes easier to train deep learning models for side channel attacks.
Really? I wouldn't have thought so. I would think you'd lose some important information.
Well, that's what I thought too, but the researchers in this paper actually proved that it works. They did all these experiments
Oh, wow, okay.
using real-world side channel data sets.
Interesting.
They tried out different types of autoencoders too, like MLPs and CNNs.
Those are the multi-layer perceptrons and convolutional neural networks.
Right. They even experimented with different compression levels, to see what worked best.
Okay.
And the results, they were actually pretty amazing.
So they found that they could train models on this compressed data and still get good results.
Yeah, they found that the models trained on the compressed data did just as well,
Wow.
if not better, than the models trained on the original big data sets.
Huh.
And get this, they even found that they could train a model on one compressed data set and then use it on a completely different one without retraining it.
Wait, really? You're kidding.
And it still worked well.
So you're telling me it's like they're adaptable.
That's the potential, like a universal key,
Wow.
that can unlock different kinds of attacks.
That would be a game changer. That would save so much time and effort in the long run.
It would. But there are limitations.
Of course, there always are.
This research, it mostly focused on first-order masking,
Right.
which is like one way to protect against side channel attacks.
The kind of countermeasure.
Yeah. They need to do more research to see how well this approach works against stronger defenses.
I see. Makes sense.
So, there's still more work to do.
Yeah.
But even with those limitations, I think the potential here is pretty mind-blowing.
Yeah, I agree. I think it's really exciting to see where this goes. I'm especially curious about the implications for transfer learning.
Oh, yeah, me too.
Yeah.
Let's unpack some of the specifics from the paper, like what they actually did.
Yeah, let's get into the nitty-gritty.
All right, let's go.
Okay, so they're actually training these deep learning models using these compressed data sets.
Right.
Created by the autoencoders.
Yeah, and they used some pretty serious statistical analysis, too,
Oh, yeah? Like what?
to make sure their results were legit. They used something called the Friedman test.
The Friedman test.
Yeah. You ever heard that one?
I have. It's used to compare like the performance of different models.
Right. So they used it to see if there was any real difference between the models trained on the original data and the ones trained on the compressed data.
Okay, that makes sense. So were there any significant differences?
Actually, no. They found that there was no statistically significant difference.
Wow, really?
In some cases, the models trained on the compressed data actually did even better.
So the compressed data is just as good, if not better.
That's what they found.
Amazing.
I know, right? It's like a win-win.
Totally.
You get smaller data sets, which makes training faster and easier,
Right.
but you don't sacrifice performance.
So cool. But remember how we were talking about making these models more portable?
Oh, yeah, yeah.
Like being able to use them on different data sets.
Yeah, could they actually do that?
Well, they wanted to see if they could train a model on one data set and then use it on other data sets without having to retrain the whole thing.
Okay, so no more starting from scratch every time.
Exactly, that's the goal. They used this third data set called ASCAV for short.
Okay,
It stands for ASCAT dataset with a fixed key.
gotcha. What did they do with it?
Well, they took those top-performing models, the ones they had trained on that DPA 4.2 dataset,
Okay.
and then they tested them on the ASCAT and ASCATIF datasets.
Without changing any of the settings?
Nope. They kept everything exactly the same, just to see if they could get those models to work on completely different data.
Okay, so like a true portability test.
Exactly. And the results, they were pretty exciting, especially with the ASCATO dataset.
Really?
The models trained on DPA 4.2, they did incredibly well on the ASCATO dataset.
So they were able to extract the secret key from a different data set without even retraining.
It's like they had learned some sort of universal language of side channel leakage.
That's pretty wild.
I know, right? But things got a little bit trickier when they tried it with the ASCAT-EF dataset.
Oh no, what happened?
Some of the models just didn't perform as well, and they thought it might be because of the specific autoencoder they used to compress that ASCAT-EF dataset.
So like maybe the compression method wasn't quite compatible with the other data sets.
That's what they were thinking. Remember we talked about different types of autoencoders?
Yeah, like different architectures.
Right. So they went back and they retrained the autoencoder for ASCAT-EF.
Okay.
And this time, they made sure that the architecture matched the other two datasets.
So like they were speaking the same language.
Exactly.
So what happened when they retested the models?
Well, the performance got a lot better.
Really?
Yeah. They found that architectural consistency was really important for that portability aspect.
That makes sense.
Like, if you want these models to work across different datasets,
Yeah,
they gotta be speaking the same language.
I get it. So they proved that portability is possible, but it depends on choosing the right autoencoder architecture.
Exactly.
That's fascinating.
But they didn't stop there.
What else did they do?
They wanted to see if they could actually use autoencoders to improve transfer learning for these side channel attacks.
Okay, remind me, what is transfer learning again?
It's like, taking a model that's already been trained on one data set,
Yeah.
and then you tweak it a little bit to work on a different data set.
Right, kind of like adapting it to a new task.
Yeah, exactly. But here's the thing. For transfer learning to work, that new data set needs to be the same size as the data that the model was originally trained on.
So there's a compatibility issue.
Right, so that's where the autoencoders come in. They use them to make sure that those compressed data sets were the right size for the original model.
Okay, so it's like they use the autoencoders to create a bridge
Yeah,
between the old model and the new data.
yeah. It's like a custom-fit training program.
I love that analogy. Did it work?
They got some really impressive results. They were able to successfully transfer models that were originally trained on raw data to work on that compressed data from different data sets.
And they didn't have to retrain the whole thing.
Nope, just a little bit of fine-tuning.
That's amazing. So they basically trained a model once, compressed it, and then taught it new tricks on a completely different data set.
That's pretty much it.
What are the implications of that for cybersecurity?
Well, I think it's a huge step towards creating more flexible and adaptable security solutions. Imagine being able to take a model that's trained to detect one kind of attack and then quickly adapt it to recognize all sorts of new and emerging threats.
Without having to start from scratch every time.
Exactly.
That's a game changer. But I know there are limitations, right?
Oh, of course. Like I said, every technology has its limitations. The researchers even mentioned some in their work. For example, they mainly focused on first-order masking, which is just one type of countermeasure against side-channel attacks.
Right.
And it's totally possible that their approach might not work as well against tougher defenses.
So there's still a lot of research to be done.
Definitely. One thing I'd be curious to see is how this technique performs against more sophisticated countermeasures.
Yeah, that's a great point. And I think it's important to remember that this is just one piece of the puzzle. There are so many different approaches to cybersecurity.
Oh, for sure. This is just one tool in the toolbox,
Right.
but it's definitely a powerful one.
I agree. It makes you think about, like, the future of cybersecurity.
Yeah.
Could we actually have security solutions that can adapt as fast as the attackers?
That's a great question. It'd be like giving our systems their own immune system.
Right, like able to learn and evolve and fight off new threats.
Exactly. And this research, it's like pointing us in that direction. Imagine security that could like automatically detect and respond to anything weird.
Whoa. and adapt to, like,
Yeah.
new attack patterns.
Yeah. And even, predict future threats based on, like, what's been happening.
That sounds like almost too good to be true.
Well, it's getting more and more realistic, with all this, like, deep learning stuff and these autoencoders.
But we got to be careful, right?
Oh, absolutely. We can't just, like, jump into any new technology without thinking about the downsides.
What kind of risks are we talking about?
Well, one big one is misuse, right? I mean, if security researchers can use these autoencoders to make better defenses, attackers could use them too.
Oh, to make, like, even sneakier attacks.
Exactly. It's like a constant back and forth.
So autoencoders, they could be great, but they could also make things worse if they fall into the wrong hands.
That's the thing with technology, right? It's not good or bad on its own.
It's all about how we use it.
Exactly. We need to have these conversations about the ethics of it all. Be proactive, think about the risks, make sure we're using this stuff responsibly.
It's not just about, like, can we do it, but should we do it?
100%.
Yeah.
As this technology keeps developing, we got to make sure it's used for good.
So knowledge is power, but it comes with responsibility.
Couldn't have said it better myself. And that's why, these deep dives are so important.
Yeah, it's all about understanding this stuff so we can make good choices.
Exactly.
Well, on that note, I think it's time to wrap up our deep dive into autoencoders and side channel attacks.
It's been a really interesting one.
It has. Before we go, I want to leave our listeners with a question. We've seen how autoencoders can make these models, portable for side channel attacks. But what about for cybersecurity as a whole?
Ooh, that's a good one.
Could this lead to, like, universal security solutions?
That's the dream, right? Something that can be used everywhere. It's definitely something to think about.
It is. And that's what I love about this field. There's always something new to learn.
Always.
Well, that's it for today's deep dive. Thank you, everyone, for listening.
Yeah, thanks for joining us.
We'll be back soon with another deep dive into a whole new topic. Until then, stay curious.
And keep learning.
See you next time.